So first of all, what is atoms? You are having little background of this chapter before.
No, ma'am, we just started.
Okay. What is atom? We have talked about the element. So if this is an element, it is made up of very minute particles. Okay, which are not visible by our naked eye. We can only watch in a very high powerful microscope. Okay, that smallest particle, okay, that is called atom. Means means what I want to say is that the smallest particle of an element is known as atom. Okay.
Okay, ma'am.
Okay, this means this means atom will show all the properties of the element. Correct? Because the element are made up of small atoms. So atoms will show all the properties which are element is having. Okay, it's basic. Okay, understood? These two lines
Yes,
meaning you
ma'am.
have understood. Okay. Okay, moving ahead toward written law of chemical composition. Law of chemical combination. This is the very first topic of this chapter. It is very important. You are having MCQ or a short answer question. Might be short answer question. Your teacher will ask, I think.
Okay,
Okay.
ma'am.
Okay. The first law, what does it state? First law is also known as the law of conservation of mass. Means law of conservation of mass. Law of conservation of mass. What does this law state? Any idea?
No, ma'am.
Something? Okay. This law states that mass, this is the conservation of mass, so we will write mass can neither be created, neither be created nor be destroyed. Okay. This is the first law. There are two laws. Second law, written, tell. I will explain you in detail also. Write it first.
Okay.
Written?
Wait, I'm still.
Okay, okay. Keep your microphone open. Okay, don't do again and again on and off. Okay, if
Okay.
there is some disturbance, then only you can mute it.
Right. Finish, ma'am.
Okay, finish. Let me explain you what does this law tells about. It tells about, first of all, the law is mass can neither be created nor be destroyed in a chemical reaction. Nor be destroyed, right? In a chemical reaction. Any chemical reaction is going on, mass will be same always in a chemical reaction. So this means this means total total mass of reactant, total mass of reactant is equal to total mass of product. Total mass of product means in the starting of the any reaction, in the starting of any reaction, if the total mass of the substance which is reacting is 25, so after the reaction when there will the product formation, the mass of the product will be 25 only. Okay, it will not be less than 25 nor it is more than 25. Okay, so this means
Okay.
total mass of the reactant is equal to total mass of product. I'm giving you a very small diagram and I will tell you how is it possible. Okay. Okay. So I'm having a container. Okay. I'm having a container. Okay. And it is a weighing balance. Okay. Weighing machine, we can say. Weighing machine. Weighing machine, you know?
Yes, ma'am.
Okay. This is weighing machine. This is a test tube. Okay. Inside this test tube, there is another tube like this, which is kept inside. Again, there is a same beaker. Sorry, it is known as beaker. Beaker, weighing machine. Okay. Weighing machine. It used to show weight. Okay. Listen to me properly. Okay. This, what we call, this flask, this flask has a solution. Okay. A blue color solution it is having. Okay. Solution it is having, which is a calcium chloride solution. Okay. This is a calcium chloride solution.
Okay.
Wait. Sorry. Sorry. This is a sodium sulfate solution. Na2SO4 solution. Sodium means Na means sodium, sulfate SO4. ठीक है? Okay.
Yes.
And this
Good.
is a flask, this black one, and it is also having a solution up to till here. Okay. I'm marking from red. It is a calcium chloride solution. Okay. Calcium.
Okay, ma'am.
So two types of solution is there in this beaker, in this flask, Na2SO4 solution and CaCl2 solution. Okay.
Okay,
Now
ma'am.
we are putting this calcium chloride solution inside this beaker, okay, and tie it with a thread, okay, and this whole solution is being closed, okay, means there is no passage of air, nothing can come inside.
Okay.
Same, same here also.
Mhm.
Draw it. Mhm. Again a beaker, and it is having solution. Right? Before keeping this, before keeping this test tube, this is known as test tube. Okay. Before keeping this test tube in this solution, Na2SO4 solution, we are keeping, we are just, someone is speaking
Okay.
outside, I think. We are taking it in our hand. Okay. This is our hand, my, okay. Okay. This is our hand. My drawing is not so much good. And this is a test tube inside it. Okay. Red color test tube inside it, and this is
Okay.
blue one is calcium chloride. Okay, we are just tilting whole things like this, okay, and mixing it. Okay, we are
Ma'am, I
tilting
have a doubt.
yeah,
Uh, you just said the red liquid is calcium chloride, right?
yeah, this is calcium chloride and this is Na2SO4. We are taking this whole beaker in our hand, and we are just tilting and we are swirling it. Okay.
Okay, ma'am.
Okay, means what does it happen? It will mix with each other. Okay, it will mix with each other. Understood?
Okay, ma'am.
And
Yes.
when we wait after mixing, when we wait this whole solution, it comes around 300.3 grams. Okay, this is a weighing scale. Understood?
Okay, ma'am. Yes.
Okay. After tilting, okay. After tilting and mixing it, now when we kept it and weighed this same comes around to 300.23 grams. And there is a chemical reaction gone between CaCl2 and Na2SO4. Okay, there is a solution. Combined solution is made. Okay, combined thing. They react
Okay.
with they react with each other and they form a solution and they form a solution. You might think, ma'am, if they form a solution, then their weight can change also. No, this is the law of conservation of mass. It means before starting any chemical reaction, the mass will be same, and after completing any reaction, the product mass will also be same. Okay.
Okay. Okay.
Okay, this was the whole experiment. When this calcium chloride reacts with sodium sulfate, there will be a precipitate which is of white color. Okay. Okay, this is a white color precipitate, but I am making it with green or what? Don't know. This white color precipitate is formed. Okay. Previously they were separate.
Okay.
Previously, calcium chloride is another solution, Na2SO4 is another solution, and the total weight of 300.23 grams. Okay, after mixing and trailing, and they form a product of white color precipitate. And when we weight it, it comes around 300.23 gram. That is same. Okay.
Ma'am, what is that white color precipitate?
What white color precipitate is the precipitate of calcium sulfate. This calcium combines with sulfate and NaCl solutions come out of the solution plus NaCl. Okay. After mixing
Uh,
these both, calcium sulfate is the product which is white in color. Okay. And NaCl comes out of the
um,
solution.
Ma'am, I have another doubt.
Yes.
Did you combined calcium with
Na2.
Na2SO4?
Yes. Yes.
But okay, so you just took the last part of calcium, right, and put the first two parts of.
Yeah. This is, I am just telling you how this calcium sulfate is formed. This calcium sulfate is formed is that this calcium react with sulfate of the sodium sulfate, and NaCl and Cl, Na and Cl is left. So they combine with each other, and calcium and sulfate combine with each other. So this is a white precipitate of calcium sulfate, and leftover is NaCl.
Okay, ma'am.
Got it?
Yes, ma'am.
Basically, they just want to demonstrate that in any chemical reaction, if you are taking two reactant, here two reactant is NaCl and CaCl2 and Na2SO4. Okay, sodium sulfate and calcium chloride. Okay, before starting the reaction, they are having a weight of 323 grams, 320 300.23 grams. Okay, total. Okay, after mixing it and after shaking it properly, they start to form a white precipitate. White precipitate means it's a solid mass precipitate or product, we can say product, है ना? Okay, this also
Okay.
weight same. So total mass of reactant is equal to total mass of product. Hence prove that mass can neither be created nor be destroyed in a chemical reaction. Understood?
Okay. Yes, ma'am.
Sure.
Yes, ma'am.
Okay. Written?
Ma'am, so but the weight will still be the same, right? When you combine it.
Yeah. Yeah. Because
Okay, ma'am.
this flask was closed. There is no incoming or passage of air is there. If this air come into play, then there will be another product formation will be there. Okay. Then also air is also
Mhm.
having some small amount of weight. It will add up. We are just taking these two in the initial and final in the product, only these two. Okay. Understood?
Okay, ma'am.
Mm.
Yes.
Shall I change the
Yeah,
page?
I'm writing now. Wait.
Okay, sorry. Wait.
Ma'am, I'm writing.
Right. No issues. Write clearly. Try to write with two, three different pens.
Um. Okay. Okay, ma'am. Mm,
Done?
Um. I'm almost done.
Okay, okay, right.
Um,
Done, beta.
yes, ma'am. Finish.
Good. Now the next law states that it is also known as law of constant law of constant proportion.
Mm-hmm. Okay.
Law of constant proportion.
Okay, ma'am.
Okay. This law states that in a chemical reaction, in a chemical in a chemical substance, the elements are always present in definite proportions by mass.
Ma'am, what do you mean by definite proportion?
Okay, I'm telling, just write it. Okay, written.
Uh, yes, ma'am.
For example, we are having water. Okay, it is made up of two elements, hydrogen and oxygen. Okay,
Okay,
hydrogen
ma'am.
and oxygen. It is having a mass of 2 grams and it is having a mass of 16 grams. H2O. Sorry. H2O. It is having a mass of 2 gram and it is having a mass of 16 gram. Because O2 atomic number is 8 and oxygen is always diatomic. So 8 plus 8 is 16. Got it? Got it?
Yes, ma'am.
Okay. So we are having water and water is made up of hydrogen and oxygen. Hydrogen atomic mass is 2 and oxygen is 16. It means they are having a proportion of, if it they are divisible by, I think, 2. 2 ones are 2, 2 8 is 16. Means 1 is to 8 by mass. Okay. This proportion is fixed. Done. That is, this proportion will always remain the same irrespective of the source of water. Whatever is the source of water, Either it is distilled water, either it is steam, either it is cold, or either it is hot. This 1:8 proportion is always be same.
Mhm.
Okay, similarly, we are having another example. Sorry. Similarly, we are having another example. Carbon dioxide, CO2.
Okay.
It is having also made up of two elements, that is carbon and
And oxygen.
oxygen. Okay.
Yes, ma'am.
What is the mass of carbon? Is 12 gram.
Uh,
Okay.
okay, ma'am.
12 gram of carbon and 32 grams of oxygen. Okay. Carbon dioxide obtained from any source will always be have the same proportion of 3 is to 8. Okay.
Okay. Okay.
Then
Um.
okay. Means it is divisible by 4. 4 3 is 12. 4 8 is 32. Means 3 is to 8 will always be fixed. And 1 is to 8 in oxygen water molecule is always be fixed. In a chemical substance, the elements are always present in a definite proportion.
Okay, ma'am.
Okay. So water is made up of hydrogen and oxygen. It is having an atomic mass of 2, and oxygen it is having an atomic mass of 6. But this 1 is to 8 ratio, not 2 is to 16. This 1 is to 8 ratio is always remain the same in any of the condition, irrespective of the source of water. Okay, so this is the second law of, understood? Second law of chemical composition. Write it.
Okay. Mm, ma'am, can you read the second sentence?
What? This proportion will always remain the same, irrespective of the source of water.
Okay, ma'am.
Okay. Write neat and clean in your note. That
Um. Yes, ma'am.
okay. Good. Now the next topic is Dalton's. Dalton is a scientist. Okay. Dalton's
Yes.
atomic theory.
Okay.
According to this theory, according to this theory, it mainly tells about the nature of the matter. What type of the matter is made up of, which type of material matter is made up of. Okay, remember with this nature of matter. So, according to this theory, all matter, uh, whether it is solid, liquid, or gas. You have already studied solid, liquid, and gas. Yesterday was your test about this. Solid, liquid, or
Yes, ma'am.
gas, or any element, compound, anything which is a matter, compound, or we can say mixture. All these thing is composed of what? Is composed of small particles called atoms. Very first like time I told you about this chapter, that is atoms. Okay, all the elements are made up of very 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 tiny particles called atoms. Called atoms.
Okay, ma'am.
Okay,
Yes.
not so difficult. So basically, Dalton
No.
has provided some assumptions, or we can say some postulate of this theory. We are going to study the postulates of of Dalton's atomic theory. It is very very important. It is mainly asked in your exams. It might be asked in your exam
Okay.
too. If it is asked, then
So
tell
what?
me, ma'am, it was there. Dalton's atomic theory postulates. It is very important. Basically, he
Okay.
provide us five or six postulate about the atoms. Okay, about the its nature, its we can say its number, how much it number, its everything about this size, its mass, everything. So he basically tell about this atom because atom is very small. Nobody has watched till now. So some scientists used to apply assumptions and they give their own theory what this atom basically is. Okay, so first of all, first theory, or we can say first postulate of this theory is that all matter, same thing, all matter is made up of very tiny particles called atom. Okay, basic very tiny particles called atoms. Okay,
Okay,
very
ma'am.
important thing, atoms are indivisible particles. Atoms are indivisible particle. Means they can't be broken into more small pieces. Okay, indivisible
Okay.
particle which can neither be created.
Not destroyed.
Yeah, good, very good. Which can neither be created nor destroyed in a chemical reaction. These 2 points are basic. Okay, anybody can learn. Now the third point. Write it
Okay.
till now.
Okay.
The third point is the atoms. The atoms of a given element. The atoms of a given element are identical Muhammad Hakim, um, better close
Yes,
your
ma'am.
gate. Say nobody will come after. Say them not to enter in your room because you are
No,
studying. Okay.
it's just it's yes. Okay, ma'am.
Okay. The atoms of a given element are identical in mass and chemical properties. Written?
Ma'am, last
Okay.
ma'am finish.
Okay. The atom of a given element are identical mass and chemical properties. Suppose suppose we are having an element that is, we can say we are having sodium. Okay. Sodium is also a metal. Okay. Suppose it is a metal. It is made up of very, very, very small particle called atoms. This you know. Okay. So this Dalton, he was saying that all these elements, all these atoms means all these indefinite and atoms are of same size. Also, they are identical. Okay, they are same in shape. Also they are having s- same chemical properties. Also means if one atom or one particle of the sodium is reacting with we can say HCl. Okay, any acid, if one part of this sodium atom is reacting with HCl, it means all the atom will react with HCl only. It doesn't mean that this particle will say no, I will not react with this, no, I will not go. Then only a chemical processes happen when all these work in a simultaneous and in a one direction matter. Okay, so this is very basic property, but it is a property. Okay, the atom of a given element are identical in mass, means their mass is same, the weight is same, and they have same chemical properties. Okay, I'm talking about one element. Okay, okay, anything one. Done.
Okay, ma'am.
But if there are more than one element, then what will happen? Basic. Okay. If there are more than one element, then what will happen? It will, sorry, black. The next point is atoms of different element, obviously atom of different element. If two or three elements are there, then they have different mass, then they have different masses, and obviously different chemical properties. This was the very first theory given by Dalton in very ancient time. Okay, for atoms. Okay, that time nobody knows about atom. So a small feature of the atom is being highlighted and being so important at that time. Okay, just now you are reading this, you might be thinking this is very basic, but that time it was much a powerful postulate. Okay, got it? Got it?
Yes, ma'am.
Okay.
Finished, ma'am.
Finished?
Yes.
Okay, tell me, what was the first law? Tell, you're having your exams, so try to learn all the points in the class only. Okay, I will ask questions. You can watch and then we can tell me because it's the first time.
Matter can neither be created nor destroyed.
Okay, means total mass of reactant is equal to total mass of product always. Okay. Okay, if
Oh,
somebody
okay.
asks you to explain this, then what will you do? You will just demonstrate with the example that I given you about calcium chloride solution and sodium sulfate solution. It is present in your book also. Okay, it might be long answer question they can ask. So you can draw this diagram and try to tell each and every basic points related to that diagram, that this is a solution of calcium chloride, this is a solution of sodium sulfate. Now we are weighing it on weighing machine by closing it from a tight clip that no air pass on the container, sorry, beaker, and they are having a weight of 300 something. After mixing the solution we get a calcium, we get a white precipitate, and you can write the product as well after giving writing this reaction as a calcium chloride react with sodium sulfate, we get a white precipitate of calcium sulfate, and then they are weighed again, the same mass came, hence proved total mass of reactant is equal to total mass of product. You will get a full marks. Understood? Understood. Now
Yes,
tell me second law. Second law is also known as what?
and the chemical substance elements are always
No.
present
It is
in a
also known as, its name is there. Law of constant proportion.
proportion. Yeah.
What does this law states? Tell. What does law of constant proportion tell us?
In a chemical reaction, in a
Yes.
chemical substance, the elements are always present in a definite proportion by mass.
Yes, definite proportion by mass. This is the statement, and you will, if it's a long answer question, then you will elaborate it by giving example of water and carbon dioxide. Okay, tell them that water is having two elements, that is hydrogen and oxygen. It is having a mass number of 2 and 6. Okay, when we will cut it by 2, that is 2 1 2 it is 1 is to 8 by mass, means this is this proportion, that is 1 is to 8, will always be same whatever kind of the water is present. Okay. Okay, write the full
Yeah.
answer by giving example, then only teacher will give you the whole marks, inshallah. Okay.
Inshallah, ma'am.
Understood?
Okay.
Understood what I'm saying?
Yes.
Okay.
Yes, ma'am.
Okay. And after that, we go to the next topic, that is atomic theory. First of all, I told you about water atoms. Atoms are the very small particle of an element. Okay. Then Dalton was a scientist who told us postulates or his thinking about this atom. Okay, that atoms are very tiny
Okay.
particles. Okay, and all matter is made up of very tiny particles called atoms. Atoms are indivisible, means they can't be broken or destroyed or created. Nobody can create it. Okay, everything can be created, but atoms can never be created nor be destroyed. Okay, next point was
Okay.
the atom of a given element. If a given element, if a one element is there, its atom will be identical, its atom will be have same chemical properties as well. Okay, everything will be same. If the
Okay.
different element we are having in our hand, then they will have different mass, different chemical properties. Understood?
Okay,
Understood?
ma'am.
It is very easy chapter. Just try to grab each and every point in the class only. Okay, that's why I'm asking question. Now, without turning your page, tell me the law of conservation of mass.
Law of what?
Law of conservation of mass.
Mm. Uh,
You're watching. Yes.
it's
No problem. Just read it again.
okay, ma'am. Um, law of conservation of mass.
Yes.
Ah. Oh, a mass. Oh, okay. A mass can neither be created nor destroyed
In a chemical reaction.
in a
Okay.
chemical reaction.
Okay. Okay. So I'm having a class with you at 9:30 also, inshallah. Then we will continue ahead. Okay. And first of all, I will
Okay.
ask this again. All the laws, all the postulates. Okay.
Okay, ma'am.
Okay. So in between 1 hour, please